Hi, my name is Nur Irdina and I am from Section 2, which is under Dr. Zuria Hati. Today I am going to show how I did my Lab 3A. So let's get started. First, I'm going to show how I did question 1, which says run this program and list the flag status after each instruction. I have already copied all these codes into Microsoft Visual Studio, and right now I'm going to build this project. So I click on build project and it says build one up to date because I have already run this project before, so it just updates the project. Next, I'm going to click on start debugging. Next, I'm going to click on step into. So here in this register window, we can see all the outputs for each register and also the flag status. So first, I'm going to click on F11, which is the shortcut key for step into. So this means that it already runs the first line of the code. And wait, I'm going to minimize this. So here is the output for the first line of the program, and I have already copied all the answer, which is OV, PL, ZR, AC, PE, and CY. So these are all the values. Next, I'm going to continue on clicking F11. So I copied each of the value after I run each line of the code, and I put the answer inside this table. Okay. So I click on F11 again. Okay, until the arrow is here, it means that it already runs the last line of the code. So I'm going to show how I copy the answer. First, OV is 0. So here we can see that I put OV is 0, PL is 0. So I put PL 0, ZR is 0, ZR is 0 here, AC is 1, AC is also 1 here, PE is 1, PE is 1 here, and CY is 0, and CY is also 0 here. So before I close this project, I'm going to click on stop debugging. So that's it for question 1. Next, I'm going to do question 2. It says what will be the values of the overflow flag in the program given below. So as what I did just now, I copied this code into Microsoft Visual Studio. Right now I'm going to build this project, and it says build one up to date. It means the building process is succeeded. Next, I click on start debugging, and next I click on step into. Okay, so I'm going to click on F11 on my keyboard so it's easy for me. Okay, here it already runs the first line of the code, but the question didn't ask for the first line's output, so I'm just gonna ignore it. Next, I'm going to click on F11 again. Okay, so the question asks the AL value when you run the second line of the code. So I've already run the second line of the code, and here in this register window we can see that the register EAX equals to 0019FF12. So as what I have studied, AL is the last 2-bit in the EAX register. So I copied this 12, I put here 12 hexadecimal, and then it also asked for UF flag value. So I find UF, or if I forget what OF is, I just refer here OF is actually OV. So here it says OV is 1, so I just put OF is 1 here. Next, I continue on clicking F11, so that runs the third line of the code. And then last one, I click on F11 again to run the last line of the code, and the question again asked for the AL value. Here we can see in EAX it is 0019 FF7D, so AL is the last 2 bit, which is 7D. So I copied that, I paste it here, AL equals to 7D hexadecimal, and it again asks for OF value, which is OV like just now. So OV is 0, so I put 0 at the OF value. So I'm done with question 2. Okay, so now I'm going to continue with question 3 here. It says define the following arrays. So first, a byte type array named PKP with 3 items, 11, 22 hexa and 4A hexa. So under dot data inside Microsoft Visual Studio, I'm going to write I'm going to define this array. So first it says a byte type array named PKP. So first we type in the name of the array PKP, like here. Next, wait, I'm going to minimize this window. Okay, next it says a byte type. So after the name of the array, we're going to write down the type of the array, which is byte, and then with 3 items, which is this. So I'm going to just write it after I declared the array type, which is 11, 22H and 4AH. So this 11 is actually in decimal because we didn't write any letters there, so it means that this 11 is in decimal. This is 22 hexadecimal and 4A hexadecimal. So next for B, a word type array named Zoom. So this is the name of the array. I'm going to put down the name first, Zoom, and then a word type. So the type of the array is word. I'm going to write down word here with 5 items, all of this. So I'm just going to copy that and I paste it here. So this Zoom array have word types data, which is all this. Okay, next, a double word type array named Padlet. Okay, so the name is Padlet. I write down Padlet here. Next, double word type. So when double word, we write D word. And then with 5 items initialized to 0. So when 5 items initialized to 0, I write these things. This one means 5 items, and this one means initialized to 0. So that's it for question 3. Now I'm going to move on to question 4 using the same project file. So referring to array definitions in question 3, state the following values in the register. So I copied all of this code inside this Microsoft Visual Studio. Okay, so right now I'm going to click on build project, and it says build 1 up to date. That means that the building process has succeeded. And then I click on start debugging, and then I click on step into. So we can see a small yellow arrow here. Right now I'm going to click on F11 on my keyboard, so it's easier for me to run the code. So when I first click F11, it runs this line of the code, and you can see the output for this line. So the question asked for the value of AL, which is why I'm going to see inside this register, which is EAX. So 0019FF0B. AL is actually this last 2 bit of EAX value. So I'm going to copy 0B and I put here 0B hexadecimal. Next, I'm going to click on F11 again, and here also it asked for AL value, it means this one, 2D. Click F11 again, it asked for AX, so AX is actually this 4 bits 002D, so I put 002D hexadecimal here. Next I click on F11 again, it wants AX, so 4400, 4400 here. I click on F11, 0444 for AX, so it's the same here. Next, for F it asked for EAX, so I'm just going to copy all of this inside here, so 0000, 0000 hexadecimal. Next I click on F11, so it runs the G codes. Now it asked for AH value, so when AH it is actually this value, so 04, so I put 04 hexadecimal here. And next I click F11 again, it asks for EAX, so I copied all this into here. Next I click on F11, it asks for AX, so I'm going to copy these 4 bits 0045H. And lastly, the last line of the codes, the question asked for Padlet. So when the question asked for the value of Padlet, I'm going to go here in autos. So here we can see the Padlet value, so it says the value is this, so I'm just going to copy all this except for the 0x, because that just means that the value is in hexadecimal. So I copied all this and I put into the value of Padlet. So when I'm done with question 5, I'm just going to click on stop debugging. Okay, so right now I'm going to continue with question 5. It says write the appropriate instructions to achieve the required results based on array definitions in question 3. So I have already defined all the array from question 3 inside Microsoft Visual Studio, and here I'm just going to write all these items from this array so that I can see the actual contents in the array. So I'm just going to go ahead and write 11, because the first one is 11, second one is 22 hexa, and then third one for E hexa, the fourth one is 45, because this one is actually 0045. So we are going to write, we're going to read it like this. This is the first, second, third, fourth, fifth. Okay, so the fourth one is 45, the fifth one is 00. I'm going to delete that again, and same goes to this one. The sixth one is here, seventh, and so on. So I've already done that for all of the items. So let's move on to question 5a. It asked the codes when BL equals to 45 hexa. So the first thing I'm going to do is I'm going to find where is this 45 hexa located. So is it this one? No, because this one is 45 decimal. So I'm going to use this one, 45 hexa. So how to know what value to move inside the register? We know we have to use the register BL, but which value to move inside it? So that's why I spread out the items like this. So when it used register BL, this BL is actually a byte type of array. So that's why I'm going to start from PKP. So this one is actually, I'm going to write here, PKP plus 0. So the next one is actually PKP plus 1. The next one is PKP plus 2, and so on. So this one is plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, and so on. So we're going to find the location of this 45 hexadecimal. So I'm just going to label this, some of it, until we find the 45 hexa. Okay, so there is our 45 hexa, which is PKP plus 5. So now I know that we have to move PKP plus 5 inside the register BL. So here I write move BL PKP plus 5, which means that I'm going to move, the Microsoft Visual Studio is going to move value inside this PKP plus 5, which is this one, 45 hexa, into the register BL. So I'm going to go ahead and build this project to see if I'm doing the right thing. So it says build 1 succeeded. Next I'm going to start debugging, and next I'm going to click on step into, and step into again to run the line of the code. So here we can see that EBX equals to this value, and BL is actually the last 2 bits of EBX, so it is 45 hexa. So what I'm doing is correct, because when I write this code inside here, it gives EBX equals to this one, and BL is this one, which is 45 hexa, and it obeys the question. So that's how I did 5A. Next I'm going to do 5B. I'm just going to go ahead and stop debugging, and I'm going to write the code that I have done first. Okay, so firstly it asked the codes when BX is equals to 004AH, 004A hexadecimal. So I cannot use BL and move 4A inside BL, because it is asking for when the register BX is 004AH. But our problem here is that 004AH is this one, which is inside the array of PKP here, like I declared here. So that is why first I'm going to initialize BX to 0. So I write move BX, comma 0. So that means the system, the compiler is going to move 0 inside the register BX. Next, I can move PKP plus 2, which is 4AH inside BL, because BL is part of BX, which is the last 2 bits of BX. Okay, so I moved PKP plus 2, so the compiler will move the value inside PKP plus 2, which is 4AH, and place it inside the BL, which is going to be the last 2 bit of BX, and it's going to obey the question request. So I'm going to go ahead and build this project. So it says build 1 succeeded, start debugging, and I'm going to step into again. Okay, so first first BX is equals to 0, because I initialize it to 0, and then I'm going to step into again to run this line of code, and we can see that the value of PKP plus 2, which is 4A hexa, is already moved into BL, and BL is inside BX. So BX is equals to 004A hexa, which is exactly what the question wants. So that's how I did 5B. Okay, so right now I'm going to continue with question 5C. It asks the codes that gives Padlet plus 4 equals to this value. So just like the questions before, I'm going to find where is this 4A 4B hexa. So it is actually here, 4A 4B hexa inside the zoom array. So when we use a zoom array, we're going to start with here, right? So I'm going to rename it as zoom plus 0. So I've already done the labeling. Right now, it asked for the codes when this happens. So first thing is Padlet plus 4 is a D-word type of array. It means that it cannot use AX or AL because it is a D-word, double word. So I'm going to go ahead and use D-word. I'm going to go ahead and use EAX for this question. So that is why I first initialize EAX to 0. So I put move EAX, 0, which means that the compiler will initialize 0 to the compiler will initialize EAX to 0, and then I'm going to move AX zoom plus 6, which means that the compiler will take this value 4B and 4A, because AX is a word type of data. It means that it has 4 bits, right? And that's why if I put zoom plus 6 inside AX, it will go ahead and take this and this. Okay, don't worry, we'll see the result after this. And then I'm going to move the value of EAX, because AX is part of EAX. It's the last 4 bits in EAX. So right now I'm going to move the value in EAX into Padlet plus 4. So let's go ahead and build this project. Okay, so once succeeded, now I'm going to start debugging. And I'm going to click step into again. So first I initialize EAX to 0 as what we can see here. So EAX equals to 0, and then step into again. So now we move zoom plus 6 into AX. So supposedly it only will move this value, but because AX is a word type of data, it will get 4B and 4A hexadecimal. So that is why this AX is equals to 4A and 4A 4B hexadecimal. Next, I click on step into again, and it runs this line of code. So we can see that the value inside EAX should be inside this Padlet plus 4. We cannot see that here, but it should be true because Padlet plus 4 was initialized to 0 at first, and then when we move the value inside EAX, which is this one, we move into Padlet plus 4. So Padlet plus 4 will have this exact value. So it obeys the question, which wants us to get the code for Padlet plus 4 equals to this value. So this is the code that I wrote for this question, and it's true that when we write this code, Padlet plus 4 will equals to this value, which we can see inside EAX. So that's how I did question 5C. Okay, I'm going to continue with question 6, which asked write a program to some array PKP. So array PKP is all this, just like in question 3. Right now I have already copied all this code that I wrote so that we can see how it works. First, we are going to move the value inside PKP into the register AL. So what this code means is that the value inside PKP, which is the first value, which is this one, 11 decimal, will be moved into register AL. So here let's just go ahead and build this project so that we can see the output and we can see that if I'm doing the right thing. Okay, succeeded. And then I'm going to click on start debugging and I click on step into again. Okay, so first, just like what I said just now, we move the value of PKP, which is the first value of PKP, because just like how I listed down just now, PKP is actually this, right? PKP plus 0. So the value is actually 11 decimal. So when 11 decimal moved into the AL will contain that value, that value of 11 decimal. So this one I write the value in hexadecimal. So 11 decimal convert to hexadecimal is 0B hexadecimal. Next, the AL register has already, the AL register is already holding the first value in PKP array, which is this one. So to sum all of the value inside the array, we are going to add the value in the array one by one. So after we have moved in the value of the first value inside the array, we are going to add the next value inside the array to the register. So I write add AL PKP plus 1. It means that AL will be add with PKP plus 1, which is this one, 22 hexa. So when we go ahead and step into, AL is now 2D. So it means that 0B hexadecimal plus 22 hexadecimal is equals to 2D hexadecimal. So and lastly, we are going to add the last value inside the array, which is this one, which is also known as PKP plus 2. So I click on step into again, and we can see that AL is now 77, which means that 2D hexadecimal has been added with this value inside here, which is 4A hexadecimal. That gives us the answer of 77 hexadecimal. So which means that 77 hexadecimal is the total sum of PKP array. Right now I'm going to continue with question 7. It is actually the same as question 6, but now it's asking to sum the array zoom. So I'm going to do the same thing just like what I did in question 6. But in question 6, notice that I use the register AL because PKP is actually a byte type of array. So it means that it only has 2 bits. So I use AL register, and now it is asking for array zoom summation. So I'm going to use this register, which is AX, because AX is also a word type of register, so it can hold 4 bit. So first I'm going to move the first value inside zoom array, which is this one, 45 decimal. This is actually equals to zoom plus 0. Next, okay, right now I'm going to just build the project so we can see the output. Okay, so next I'm going to click on start debugging. I'm going to click on start over. So I'm going to click on step over on my keyboard. Okay, so the first line means that we are going to move the first value inside zoom array into the register AX. So AX will contain the value of the first value inside zoom array, which is 45 decimal. When we convert 45 decimal, we will get 2DH, just like what we can see here in this register window. AX is equal to this, but AX is equals to this 4 bits. Next, we click on F11 again to run the next line of code. We add the we add the contents in AX with the value of zoom plus 2. So zoom plus 2 is actually the second value inside zoom array. So some of you will ask why we don't use zoom plus 1. It is because zoom plus 1 is actually 0, like this. Let me just show a quick example. So this is zoom plus 0, this is zoom plus 1, this is zoom plus 1, this is zoom plus 2, and this is zoom plus 3 actually. But then when we put on zoom plus 2 but we move into the AX, it will give the 4 value inside this value. So that is why we use zoom 2 and move into AX, so it will hold this value 0045 hexadecimal. So so this is how we read this array. This is zoom plus 0, zoom plus 2, zoom plus 4, zoom plus 6, zoom plus 8. So we are going to add the contents in AX with the next value, which is zoom plus 2. So it will give the answer AX equals to 0072, and then we click on F11 again. Now AX is already added with the third value in zoom array, which is zoom plus 4, which is this one. So now the AX value is now this. Click F11 again, it will going to add the next value in zoom array, which is this one. AX will equal this one, and click on F11. It will add the value inside AX with the last value inside the zoom array, which is this one, and AX will show that it contains the value of this one, which means that AX is this one, which also means that the total sum of this whole array is 534B hexadecimal. So I just copied all this code into this question area, so we can see the code and we can see the result or the contents in AX for each line. So the last one will be the total sum, which is 534B hexadecimal. Now I'm going to continue with question 8, which says study the assembly instructions below and fill in the blanks in hexadecimal. So I've already copied all this code inside this Microsoft Visual Studio. Right now I'm going to just build the project. It says 1 succeeded. Now I'm going to click on start debugging. I'm going to click step into. So I'm going to click step into again on my keyboard, which is F11. So it will run the first line of this code because the question is asking for the value in EDI. So when we run this first code, we can see that when we run this first line of code, we can see that in register window it says that EDI over here is equals to this value. So I just copied this value into this answer area. Next, it is asking for ECX value when the second line of code has been run by the compiler. So I click on F11 again, so we can see the ECX value here, which is 4 hexadecimal. So I just copied again the value inside this to here. So this first line actually means that the compiler moved the address of this in array into the register EDI. So EDI is equals to address of in array. So the next line means that the compiler moved the length of in array. So the length of in array, we can see that here is 4 hexadecimal because it has 4 value, 1, 2, 3, and 4. So that is why ECX is equals to 4. And by the way, ECX is ECX always acts as a register that counts the value inside the array, or we can also call ECX as counter. So when we move this, it means that we move the length of in array into ECX, which is 4. So next, it is asking when this for this line. So we're going to click F11. So when at EDI type in array, it is actually EDI equals to EDI plus in array, because we add EDI with in array, which means that for example, for the first time it loops through this line of code, it means that EDI is going to add the first value inside this in array, and then when it has moved to the next loop, it will add the second value in this array, and then when it loop again, it will add the third value, and so on. So this means that EDI equals to EDI plus in array, and it will follows the number of loop. And for example, if it is in loop 1, it will add the first value. If it is in loop 2, it will add the second value, and so on. So I'm going to run this code until we achieve this line. So click on F11. Wait. Okay, F11. This is second loop, third loop, fourth loop, and we go to the move total. So when we run that, we can see that the value total is here, this one, which is 0A00 hexadecimal. So that is why I put 0A00 hexadecimal here, which is the total sum of the value inside this array. So that's how I did question 8. Okay, now we are going to move on to question 9. It says study the assembly instructions below and answer the following questions. So I just copied all this code into Microsoft Visual Studio, and the first question asked how many times will the loop be executed. So my answer is 4 times. It's because we can see that we move the value of 4 inside ECX. So as I mentioned just now, ECX is actually the counter, or the loop counter. So when ECX is equals to 4, it means that the loop will be executed 4 times. Next, B, what is the final result of AX in hexadecimal? So I'm going to build this project. And I'm going to click on start debugging. Next, I'm going to click on step into. Because it asked for the final result, I'm going to go through the loops by clicking F11. First loop, second loop, third loop, fourth loop, or the final loop. So we will get the final result of AX here. We can see that AX is this one, so AX is 0014 hexadecimal. So that's how I get the answer for AX in hexadecimal. Next, it wants us to fill in the table with the value of AX after each instruction in each loop. So it means that I have to run this project again. So I've already built it, so I'm just going to start debugging again. So I'm going to click F11. So it says initially AX is equals to 20 decimal, which is also 14 hexadecimal. So when we click on F11, so in the first loop, when we increase AX, the answer for AX is this 0015. So I put here 0015 hexadecimal, which is also 21 decimal. I just put both because I'm confused if the question wants the hexadecimal or decimal value, so I just put both. Next, we want to see if we negate AX, what will be the value. Is actually this FFEB. So I put here FFEB hexadecimal. So we F11 again, we are going to run in the second loop. So we press F11, we increase AX again, the answer is this, FFEC. Click F11 again, we negate AX, 0014, the answer, so I put 0014 here. Click F11 again, we are going into loop 3. Click F11, we increase AX, so 0015 is the answer for AX. Next, I click F11 again, we negate AX, FFEB, so I put here FFEB. Click F11, we are going into the last loop, which is the fourth loop. We increase AX, the answer is FFEC, and we click again F11, negate AX, which is 0014. So 0014 is the final answer for AX, which is the same as question B. So that's how I did question 9. So right now I'm going to continue doing question 10. It says, study the assembly language code given below. What is the final value of the variable total? So I have already copied all this code into Microsoft Visual Studio. Right now I'm going to just build the project because it is asking for final value of variable total. So it says build one up to date. I'm going to start debugging and click step into. Right now I'm going to click on F11. So here we can see that the counter is 7, so it means that it will loop 7 times. The loop will be executed 7 times. So I'm going to click on F11 to run all the code. So first loop, second loop, third loop, fourth loop, fifth loop, sixth loop, seventh loop, or the final loop. So it is asking what is the final value of the variable total, but here it is the value for EAX. So we are going to move into the next line, which will move the value inside EAX into the variable total. So here we can see that the value of total is this 70 hexadecimal. So that's how I get the answer. That's how I get the final value for the variable total. So I write here 70 hexadecimal or 112 decimal. So this code's actually every time it loops, it will add 10 hexadecimal into the value inside the EAX. So that's how I did question 10. So let's move on to the final question, which is question 11. It is asking, using the loop instruction, write a program to achieve the following equation. So the following equation is this: total equals to 100 hexadecimal times 7 hexadecimal, and it is asking for the final result of total in hexadecimal and decimal. So reading this question, I actually interpreted this question as it is asking us to do the code using loop instruction, and the ECX or the counter will be 7H because it is 100 times 7H. So this is actually the same as total equals to 100 hexadecimal plus 100 hexadecimal plus 100 hexadecimal until 7 times. So it means that it wants 7 times of loop, and for each loop we will add 100 hexadecimal into the contents of the register. So that's what I'm going to do. So this is why I write this code. First, I declared total dword equals to 0. It means that the variable total is initialized to 0, and then I declared counter dword 7H because counter is going to be the number of our loop, which means that the loop will be executed 7 times. So in this main prod, we first move 0 into EAX. So we initialize the value inside the register EAX to 0, and then we move counter into ECX, because that what ECX usually do. It acts as a counter or the loop counter. So we're going to put this L1, which means we are going to use the loop instruction, and for each loop we are going to add 100 hexadecimal into the register EAX. So it will go through this loop 7 times, and then after that, when it has already been executed 7 times, we are going to move the value of EAX into the variable total. So the total will hold the final result in hexadecimal. So we're going to go ahead and build this project. Click start debugging, click step into. So I'm going to just run this by clicking F11. So here we can see EAX is initialized to 0, and then we click again, we can see that ECX is 7, which is the loop counter is 7, and then we are already in the first loop. We add EAX with 100, so EAX is now 100. So we are going into the second loop, run the code, and EAX is now 200 hexadecimal, because we add another 100 hexadecimal into EAX. So now third loop, EAX is already 300 hexadecimal. Fourth loop, EAX is 400. Fifth loop, EAX is 500. Sixth loop, EAX is 600, and the final loop, we can see that EAX is 700. This is actually equivalent to 100 hexadecimal times 7 hexadecimal, and then we are going to move this value inside EAX into the variable total. So we can see here the variable total holds the value of EAX, the same value 700, and inside total is also 700. So that's how I get the answer for this question, which asks the total equals to 100 hexadecimal times 7 hexadecimal, and if we calculate manually by calculator, it will give the answer 700 hexadecimal, and it is the same as what I get here. Total is equals to 700 hexadecimal. So it is also asking what is the final result of total in hexadecimal. So the answer is 700 hexadecimal, and if we untick on the hexadecimal display, it will give us this value 1792, which is in decimal. So this is in hexadecimal and this is in decimal. So that's how I did question 11. So that is basically how I did each question in lab 3A. I hope that all of my answers are correct, and some of the lessons that I learned throughout the process of doing this lab 3A is that I learned that we should not ever give up. Like sometimes I write the code, but then at the output it says the build process is failed, which means that my code has an error. And sometimes I also write a code and it gives the different output than what I wanted. So I didn't give up, but then I keep trying, and sometimes I just ask for a help from my friends, so until I get the correct answer. So I think that is kind of tiring, but in order to achieve the best result, I will do anything to get the best result. So the first lesson is that we should not give up, and then the second one is that we should not feel shy to ask for help. Like it's okay to ask for help from other people. Like it doesn't mean that you are weak, but it just means that you want to share the knowledge with other people. So it is okay to ask help from other people, and it is good if you share your answer with other people. Like, it's not like share means other people can just copy the answer from you, but share means like share how you do it, like how you understand the question, how you interpret the question, how are you going to make the code work as the question wants it to be. So yeah, the second one is do not be ashamed to ask for help. And yeah, I think that is all for now, because for me, for now, I have not reached the difficult part yet, because I think for now the questions are just asking for the output, and they are just asking us to copy the code and just run the code. So we can just like copy the output from Microsoft Visual Studio into the question area. But I don't know, this basic thing is important for me, because later in the future there must be more difficult question that I have to deal with. So these basic questions are good for me to build my confidence and to build my understanding towards this project or towards this chapter. So it's good that we have many labs exercise to do, and I kind of like labs exercise because I don't know, I have fun doing it. So yeah, I think that is all for me. I'm sorry if some of my explanation is not that clear, and I think that is all from me. Thank you.